This video is possible thanks to contributions to the Existence University Patreon by viewers like you. Thank you.
Hi, I'm a Canadian YouTube educator, and as such, my audience mostly consists of Americans. So I would like to address a concern I have with the American education system. There is this program for international student assessment, and as such, it has this list of all of the different countries from the different nations. International. You can see here on the Canadian one, it has both a French and an English version, as we tend to do. And if we just click here on the English one, what we find is it brings us to a PDF. Now we can scroll through the PDF and find what we want to find. And we can say, click here, and it will bring us down to the conclusions, and we can find the information that we are looking for. All on this big PDF, as you can see. Now, here's one of my concerns. The scores, if I just look here at the tables, say, which has the Americans and the Canadians on it, overall, there is a significant statistical difference in math and science between the Americans and the Canadians, but not in reading. The Americans and the Canadians are statistically better than the average in reading. But my concern is that I don't know if these numbers are inflated or not. See, here's my issue. Again, the Canadian version gets us a PDF. Here, when we come down to that list again, and we look at the American one, we click on its national report, what we find is a page with little icons and little boxes to help direct your attention. No PDF, small amount of information. A calculator to let you know that it's the math section. A book to let you know that it is the reading section. A microscope to let you know that it is the science section. And a wallet for financial literacy. It would appear to me that the scores Americans might receive might be a little bit artificially inflated. For I have found that if someone is an American and they have a PhD or a master's degree, there's no reason to believe that they took the classes necessary, I would find. It's almost as if, as we can see just by the documents, just for students about 15 years old, if a student 15 years of age in Canada wishes to know how he did on his assessments, he has to read a 200-page document. The Americans, I can't even find the PDF. They don't show it. They won't. Did they even make it? Do they know how to write one? I'm concerned. This is the issue going forward. So let us look at some numbers. We can see here in the math section, the average across the international, all the different countries, the average was a score of 472. Canada, the average score in Canada was 497, and in the United States was 465. So what we have here is Canada was significantly higher than the average, and in fact the US was significantly lower than Canada. So anyways, I just wanted to address this as a concern of mine as a Canadian educator providing YouTube education, therefore providing education mostly to Americans, that sometimes it seems that there's a gap between what I think is the expected and what other people have as a level of expectation. And I will work on that. But in the meantime, we can do induction with rocks. 2 plus 3. Two objects put into a group of 3 objects gets us 5. 5 minus 2. 2 objects taken from a group of 5 objects. 2 times 3. 2 groups of 3 objects. 6 divided by 2. 6 objects into 2 groups. 2 to the power 3. 3 groupings starting at 2 objects. Log 2 of 8 equals 8 objects ungrouped into 2 objects. The answer is 3. Cube root of 8. That's 3 ungroupings of 8 objects, which gets us 2 objects. Make sense? Okay. So, imagine that we don't have numbers yet. We could start by saying, if we have a bag of stuff and we don't have anything in it yet, we will call that nothing. And we'll just put a line there. Nothing's there. If we have a bag and there's one thing in it, we will make a little triangle. It's got one point. The point indicates one object. We add a second object. We add a second point. Third object. Third point. We stop here because the hand has 1, 2, 3. So the first finger counts to 3. So we have 1, 2, 3. 1, 2, 3. So when we get to the next object, here we also have, I want to go that way. No, I want it to go this way. Nothing. It's got no corner. When we get to 4, we're going to say 1, nothing. 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's one hand. One handful. 1, 1, 1, 2. 1, 3. Just like this, we repeat. So we have to go 2. Nothing. 2, 1, 2, 2, 2, 3, 3, nothing. So we could write this out in a, let's just write it all the way down this line. can also write it along the top. I'm not going to do nothing or do it here. Keep the same nothing. How about that? I'm just going to stop here at 1, 3, which is, we're at 3, 4, 5, 6, 7. Just write them all up. Nothing. 1, 2, 8, 9, 10, 11, 12. So we stopped here. That's 1, 2, 3, 4, 5, 6, 7. Stopped at 7. So in here, we can fill this out with addition, subtraction, multiplication, division, whatever. That's up to your imagination. We just want to know what the relationship is when 1 meets 1, when 1 meets 2, when 1 meets 3, and when 2 meets 2, when 3 meets 3, which will follow, that pattern. So, go 1 plus 1. We'll do pluses. 1 plus 1, 2. 1 plus 2, 3, 4, 5, 6, 7. Let's stop at 7 both ways. So we'll do one more just to get to 7, which gets us 8. 2 plus 1, 3. Well, actually, look, we have 1 and we can go this way, right? That's 4, 5, 6, 7, 8. 8, 8. Pattern repeats along this diagonal. Okay. So here we have a grid created for adding. 1 column, 1 row, 1 plus 1 is 2, 2 plus 1 is 3, and we can see that it's actually a number line, just because we're lining them up, just in order of stacking one object. We line them up, and we find, if we put them in columns like this, each one of these is the number line shifted 1 over. It's actually shifted down the number according to how many we've gone down. So shifted over by 4 gives us 4 at the spot. This is starting at nothing, shifted over by 1, shifted over by 2, shifted over by 3, 4, 5, 6, 7, 8. So these numbers are just coming from up here, but way off in the distance. And it will keep happening, such that every time we create a new number, like this one, then when we write it here and here, it's going to add together to be double its size, which means it's a number. So we add that to the list, and we keep going. And it goes on forever. Here we can see some patterns. Since the list is being shifted over by 1, we have a pattern where the numbers are taking some diagonal. So these are the 1 line, the 2 line, the 3 line, the 4 line. And there's a series of lines that cuts through. So there's also then an infinite number of lines, interestingly enough. So then we want to introduce the idea that we're grouping things in different ways. So let's have some system where we say something like A add B equals C, and one where A minus, or A subtract B equals C, and a system such that A multiply B equals C, and a system where A can divide B into equaling C. And we will have a system, a different set of systems. Let's go A to the B equals C. This type of grouping is that A grouping of an A grouping of an A amount, which we will see in an example. The reverse of this then would be A C equal B and B C equals A. These two are the reverse of this one, just as this one is the reverse of that one, and this one is the reverse of that one. It just so happens that the way this pattern is shifted, the way this is added together, causes us to not be able to simply reverse it, and we will see that in an example. But for the time being, we will use this. We could use this kind of notation. And in fact, we kind of just want to simplify it. So if I'm going to just extend that and just focus on that. For the E, I'm just going to focus on those. For the S, I'm just going to focus on that little thing. For the M, I'm going to cheat a little bit and just kind of let these lines cross and focus on that. I'm going to focus on this section of the D, and we're going to fix that in a second. So let's just fix these. So focusing on that part of the D, it's just a line. Focusing on that part of the M, it's just an X. Focusing on that part of the S, it's just a line. Focusing on that part of the A, it's just a little plus. Focusing on this part of the E is a little boop boop. And we get that all the way, boop boop. Boop boop, boop boop. You can see I already did it here. Cheated a little bit. Okay, this is going to be confusing, because what if I have A, B, B, C? Right? Does this B belong to that A or does it belong to that C? So you know what I'm going to do is I'm going to specify a little box here, but I'm lazy, so I'm not going to draw a whole box. So I'm just going to say that. So now I know that it's A to the power B times the root B of C. And here, if I have A, C, did I write small? Or is that actually a reverse of this? So what I'm going to do here is I'm actually going to just say what I'm doing. It's a logarithm. The log of A is C. And that's how I will get past that. So I'm going to say root B and log. And there we have it. So then we can start doing certain things like 12 divide by 3, which is 12 objects One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, divided into 3 groups. That would leave us with groups of 4. 4 objects times, oops, that's not our 4. 4 objects times 3 objects equals 12. 12 divided by 3 equals 4 objects. This is groups. Or, because the pattern can be flipped in a sense and looked at in different ways and it doesn't change anything, then this could also technically be our objects and this could be our groups. We lose no information. If we did 8 to 1, that would be, where are these lines? Oh, let's just get rid of all of it and start over. 1, 2, 3, 4, 5, 6, 7, 8. The log, take the log of 2 of 8, and that would be how many times this was grouped, which would be, it was 2, and then 2 to the power of 2 be this, and then you double that. So that took 3 operations. It would be, 3 operations. It would be 2 to the 3. Alternatively, we could take the third root of 8, in which case we split this into 3 equal parts. How do you see it? Let's start with 2 objects going in 2 dimensions. So if you think about it as 2 objects going in 2 dimensions, going in 3 dimensions, x, z, y, because that's what cubing it would mean. You'd be moving this guy in 3 dimensions, so that's 1, 2, 3, 4, 5, 6, 7, 8. Does that make more sense? I think so. Okay, let's look at some rock examples. We want to be able to have 2 different types of grouping operations. One, where we can say we have 2 objects in one group, three objects in another, and this symbol, this add symbol, means to take these objects, just these 2, and to just place them into this one. And we get this. A second type of operation, using a different symbol, tells us how to group them in a different way. This one reads, take 2 objects and add them to the 3 objects. This symbol has a different meaning. It reads 2 groups of 3 things. So this symbolizes that we're dealing with groups,
not necessarily just objects. 2 groups, that's one group of 3 objects plus another group of 3 objects. When we do exponents, say something like 2 to the power of 3, this is actually symbolizing that we do what is essentially 2 groups of 2 groups of 2. So this one up here could be written in a sense as 2 to the 3 gets a 6. This symbolizing system tells us how many times we do this type of operation, but the number will be the same number as what is called the base. So we could write this in our symbol form as 2 times 2 times 2, or as we just wrote it, as a set, like this. Where when we write it like this or this, we're saying 2 for each group of these and 2 groups of these. So it's a group of objects. If we change that to 2 to the 4, that would be 2 to the 2 to the 2 to the 2. So 2 groups of 2 groupings of 2 groupings of 2 objects. Visually, we can use rocks. So if we start with 2 objects and a group of 3 objects, 2 plus 3 means to take these 2 objects and to just physically put them into the other group. To multiply is to take, say, a grouping, 1, 2, 3, and if we were to multiply it by 2, that means it doesn't mean to add 2 objects, it means to have 2 groups with 3 objects in them. The exponent is like taking a base number, like 2, as the first group. And the second grouping would be to take these, separate them, and make each unit now look like the old set. So this unit now has 1, 2. It looks like it used to. It's fractal. Now we do it here. We can do this one more time, because that's group 2. 2 to the 3. 3 groupings of 2 gets us 2, 4, 6, 8. We try that with a different number. Let's try 3, 1, 2, 3. And we will go to the third power. So this is 3 to the power of 1. 3 to the power of 2 would be to make each one of these look like the original. So they get 3, not 2, right? Because it's 3. So now they look like the original. So that's 3 squared, or 3 to the power of 2, which is 3, 6, 9. That works out. Then we do it again. here we get 3, 6, 9, 12, 15, 18, 21, 24, 27. 3 to the power of 3, 27. When we're multiplying, let's take these guys. 1, 2, 3, and we times it by 2. So we make 2 groups of 3. And we get 6. We could also see, just visually, that instead of having 2 groups of 3, we also have 3 groups of 2. So in multiplication, because we've only done this grouping process once, the group and the objects are reversible. 3 groups with 2 objects is 6 things, and 3 groups, or 3 objects in 2 groups is 6 objects. So when we divide, you can divide by either the group or the object, and it will work out either way. However, when we do exponentials, let's do 2 to the power of 4, so that's one group, so that's 2 to the 2, so that's 2 to the 3, and therefore this is 2 to the 4. 2, 4, 6, 8, 10, 12, 14, 16. 2 to the 4 is also 4 squared. 1, or 4 times 4, which we can see visually right here. There are 4 groups of 4 rocks. 4 times 4, 16. Let's do 2 to the 3 again. 1, 2. This is 2 to the power 1. So that's 2 to the power 2. So that's 2 to the power 3. We therefore have 2 ways of reversing this, because one of the ways will tell us how many times we need to repeat the process, and one answer will tell us how many are left. So we have, in one case, log 2 of 8. The answer will be 3, because it will tell us how many times, it will tell us the power that we get here. It will tell us the amount of groupings. So this is grouping 3. This was grouping 2. That was grouping 1. So log 2 to the 8 tells us that it took 3 powers. 1, 2, 3. The cube root of 8, however, tells us what value, what the base is at the beginning. So division is just reverse multiplication. However, because exponents have a kind of double process where this and then this has to occur, you cannot just simply reverse it. And so there are 2 operations to get us back to normal. One gives us how many powers it will take us to get to this point. So log 2 of 8 is 3, because it takes 3. And the cube root of 8 tells us how many units or how many objects there were at the very start, which is 2.